Here we are asked to solve for the general solution of this equation for theta elements from negative 270 to 0 degrees. All right, let's look at this equation. We have cos 2 theta plus 3 sin 2 theta equals to minus 1. So the first thing that I'm going to do here is to move the minus 1 to the left. So I'll just write cos 2 theta plus 3 sin 2 theta, and then we transpose the minus 1 to become a positive, and then we have 0. Right. So this identity here is a double angle, and also this one is a double angle, right? And the one for sine, it's easy to change. I can always change it first because it's always, okay, let me write 3. It's always 2 sin theta cos of theta. Then you have plus 1 is equals to 0. The one for cos 2 theta, remember cos 2 theta has 3 possible identities. Let me write them quickly. The first one is cos squared theta minus sine squared theta, right? And then it's 2 cos squared theta minus 1. And then it's 1 minus 2 sine squared theta. We need to be smart about which one we are going to choose in this case. I look at here, I have plus 1, right? I have plus 1 there. So I'm going to always, if I have plus 1, I'm going to always choose the one that has minus 1 so that those ones can cancel. If I had minus 1 there, I was going to choose the one with a plus 1 so that the ones can cancel. So the ones you're always wanting to cancel them. So I'm sure, ladies and gentlemen, you can see that we're going to take this one, right? The 2 cos squared theta minus 1. So let's write it. 2 cos squared theta minus 1. The reason we picked that, we needed to have a minus 1 so that we can cancel with that one. And then those ones have cancelled, so now we are left with 2 cos squared theta plus 6 sin theta cos theta equals to 0. 3 times 2 is 6. And then now, ladies and gents, after changing to identities and adding like terms, we are always going to factorize. Either be a trinomial, difference of 2 squares, or highest common factor. And in this case, I can see a highest common factor of 2 cos theta. Then on the first term, I'm just left with cos theta. And then on the last term, I'm left with 3 sin theta equals to 0. Now I can apply the zero product principle. Remember here, it's like we have a bracket as well. So the first bracket will be equals to 0, or the second bracket will be equals to 0. And then if we check here, divide both sides by 2, you just have cos theta is equals to 0 still. Then this side, if you have 2 terms, and it's like you have this form, a cos theta equals to b sin theta, you can always divide by cos theta to change into 10. So in this case, I have 2 terms. So I'm going to write cos theta equals to negative 3 sin theta. And then I'm going to divide both sides by cos theta. But because I'm dividing by cos theta, it means cos theta cannot be 0 because division by 0 is undefined. So we can agree that that cancels the first part of the solution. We cannot allow cos theta to be 0 because it's a divisor, and a divisor of 0 is undefined. Then taking that to here, we get 1 equals to negative 3 sine over cos is tan of theta. All right. Then, ladies and gents, let's check here. We're going to have a negative 3 dividing both sides, and then we're going to have tan theta is equals to negative 1 over 3. All right. So now, ladies and gents, we need to do the reference angle. Remember ref angle we're going to say theta equals to shift tan positive 1/3. When we do reference angle, we always include a positive number. Even if the value was negative, we are going to ignore it when we do the reference. And that becomes 18.43. 18.43 degrees. And you can agree, ladies and gents, that from here, I'm in quadrant 2 and 4 because that's where tan is negative. So I'm going to write my solution in quadrant 2, which is theta. Quadrant 2, remember, it's 180 minus the reference, minus 18.43 plus 180 degrees K. Then you must show K element of integers. For tan, we use 180K, remember? And then we're going to say theta is equals to 161.57 plus 180 degrees K. All right. And then because we're working with tan, we're only going to do one quadrant. You are not supposed to do both because you're not going to get marks for another one. For tan, we only do one solution. Sine and cos, you do 2. All right. Now, we were told that we're only looking for the thetas that are in between here. All right. And then we're going to say, okay, theta elements, we open a bracket. On your calculator, on your Casio calculator, you type the solution 161.57 plus 180. So I type this up until there. Where there's K, I open a bracket. And then I put minus. I always start at minus 3. Minus 3 gives me negative 378, which is outside the range. Remember, the range we need from negative 270 to 0, right? We're looking for answers that are in that interval. So let's do negative 2. Negative 2 works. It's inside is negative 198.43. And then we do negative 1. Negative 1 works, give us negative 18.43. And then we do 0. 0 doesn't work. It's outside. It gives us 161. So those are the two solutions in this case. And that's it, ladies and gentlemen.